Okay, section 1.10, 2x2 scatterplots. Now, on your copy of this, you're going to have to look at Google Classroom because it's black and white. You're not going to see the color of the dots. So let's go ahead and answer some of these questions. The following graph shows high school GPAs and the SAT scores for students who applied to a particular university. Each dot represents a student and is color coded to indicate the student's admission status. Okay, A, what do the blue dots represent? Now, again, you have to look at Google Classroom and the colors because you're not going to see the clear colors, the difference between the colors on your black and white copy. So where do they seem to be clustered on the graph? Well, the blue dots looks like they're clustered in this area here. So we need to explain what they represent. So the blue dots, I'll use blue. So the blue dots represent the denied students, students that were denied acceptance. And then it says, explain why that makes sense. Well, if we look at the cluster of the blue and we look at our graph, the horizontal graph here, the SAT scores are going up. Therefore, a good assumption is that they had the lower, good lower amount of SAT scores. So makes sense because lower SAT scores. Okay, B. Where do the green and purple dots, or what do the green and purple dots represent? So let's explain that first. So here's purple, here's the green. The green is accepted, but not going to attend. Okay, and the purple ones is accepted and will attend. Okay. Are there any green or purple dots that seem to contradict the trend? Well, if we look at it here closely, there are some outliers here. There's some green ones here in the lower SATs, and some purple ones too in the lower SATs. So there definitely are some outliers. Green and purple outliers of the trend. Okay, C. Oh, I'm going to scoot this down a little bit. Okay, C. Notice there are blue and orange dots representing students who were waitlisted or denied admission behind some of the green and purple dots. So here's some orange dots that were actually ahead on their scores from these green dots, but were put on the waiting list. And they're asking, well, why is that? Well, that means there has to be other factors in the decision to accepting students. And we just don't have the information to tell what those factors are. Okay, that's 1.10, the Explore section. Discover section. This section will focus on, well, 2x2 scatter plots, on making and interpreting scatter plots. The type of graph shown in the Explorer is the scatter plot. Okay. As you progress through the section, think about these questions. When is a scatter plot the best graph to create? Do you know how to set up and scale to illustrate data on a scatter plot? And can you interpret scatter plots that someone else has created and draw reasonable conclusions? All right, in the last section, we did make bar and pie graphs, and also we did line graphs. But sometimes they're just not good enough to explain like two sets of data. And that's where the scatter plot comes in very useful. So, and we do a lot of work with scatter plots. All right, here's the formal definition. A scatter plot is a graph that shows the relationship between two quantitative variables. Horizontal axis is used to represent one variable, and the vertical is the other variable. Now, back when you were learning slope in graphs, okay, we had the x-axis and the y-axis. And we always used to say that y was dependent on x. In other words, x was always the independent variable. And y was the dependent variable. Input, output. So whatever it was whatever the input of x was, that's what y depended on. And this is really important when we're doing scatter plots and interpreting, and also when we make the scatter plots. This is a scatter plot. There is something when we go to make our scatter plots. Many times our scales don't start at 0. And what we want to do, just to give a heads up to people reading these charts, is we call this little break here jagged. So we want to make sure that if it doesn't start at 0, because we're going to have to make our own scales on our scatter plot. If it doesn't start at 0, it's really helpful to people who read these. It has a jagged start. All right, let's go on. And here's a formal explanation on dependent and independent variables here. Just remember that the independent variable is what you choose, or the x-axis, and the dependent variable is the y-axis. All right, then after you choose which variable is independent and which variable is dependent, you have to come up with a scale. Your scale for your axis. And that scale is going to tell us, the easiest way to do it is you figure out what your lowest value is from the data, and at one end of the spectrum, and then you have your highest value. And you see what the difference is. Suppose we're doing test scores. It could range from anywhere from 0 to 100%. So a good scale here, would probably be because we don't want a huge graph with increments of 1. Maybe we do it by 5 or 10. It depends. 10's it's getting a little big, but usually around 5. We can even go 2. If we do 2, remember you're going to have 50 marks. If we do it by 5, we should end up with 20 marks, which isn't that bad. So that's what we mean by scale and the increments. The increment is what each one of these, from 0 to 5. So this is 5 increments. And it takes a little bit of practice to get used to this. All right, let's look at the example that they have here. To create a scatter plot to represent the following data, GDP stands for gross domestic product. It is given in international dollars. So here's each country. Here's their GPD per capita, and these are given in dollars. And then the percent using social media. So what we have to do first, they have a little step-by-step process of how to make a scatter plot. We'll get to it in a minute. So the first thing we're going to do is it makes sense to think the percent of the population on the social media depends on the wealth of the country. In other words, the number of people, the percentage of people that use social media depends on how high that capital is or how wealthy that nation is. Makes sense, because the wealthier it is, the more people are going to have social media devices. So we're going to put the GPD, this is going to be our x-axis here. Our independent. Then this will be our y-axis. It depends, the social media depends on the wealth. And they did that for us. Okay. Put the gross GDP on the x-axis and the percentage of people using social media. And they have a little explanation here. First, they chose which one was dependent, x-axis, y-axis. This one was independent. This one was dependent. GPD was the dependent. Independent. Keep screwing that up. All right, minimum value. If you look at our chart, the minimum value was 10,000. Actually, Pakistan had 3,000. So it's a good. So the minimum value, they're going to start their scale at 0 because 3,000 isn't that far from 0. When we're talking about 60,000, the max was 60. On the percentage of people using it, we had a maximum of 60%. So we're going to go with increments of 5. Minimum 0 to 60%. So we're going to start with 0 on both. And then on the dollars, increments of 5,000, so 5,000, 10, 15, 20, so forth. And the percentage, same thing, 0, 5, 10, only 5, not 5,000. And then they put each data point in there, each country, and they labeled it to make it clear. All right, so let's look at our problem that they want us to do. So I have, here's my data. I have experience. So here, let's read this. Consider the following data on years of experience and salaries of the employers of a small business. So that, don't forget the title of the chart. In fact, here's the steps. I would make the title right away so I don't forget what my title is. So this is going to be years of experience. Because I usually end up forgetting my title. And salaries. Okay, here's my title. So the independent variable, well, if I think about this, one is going to be more dependent on the other. And that is, for me, I'm going to think that, hey, the amount of money I get is going to depend on the years. So my independent variable here is, since my salary is going to depend on how many years I work, my independent is going to be years experience. And the dependent is going to be our salaries. Salaries is going to depend on how many years I work there. Okay. I should have made this a different color. Make it green. So this is going to be my x-axis, or my horizontal. This is going to be my y-axis, or vertical. Minimum value for my years, well, it's going to be 0. The maximum value for years is 23. So I'm going to do increments. Actually, let's see, increments of 2 should work. And again, there's no magic way of doing that. You just don't want it too small and you don't want it too big. Okay, for the salaries, my minimum value, well, my lowest one is 48,000. So I'm going to start at 40,000. My maximum value is 92. I should put 48. And my maximum is 92. So I'm going to go in increments of say 5,000. Okay. So my x-axis is the experience, years of experience. And my y-axis is going to be my salaries. And it's going to be in dollars. Okay, so for the x-axis, I'm going to use increments of 2. I'm actually going to start at 0 here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And my salaries here, well, I'm going to do that break thing here. And I'm going to start at 40,000, 45, 50, increments of 5,000, 55, 60, 65, 70, 75, 80, 85, and 90. I should go 95. I could have probably made a little bit bigger than 5,000. I'm going to shrink this up. Dollar salaries and thousands. Okay. So now I'm going to take my data and just like an ordered pair, I'm going to start putting my points in there. Okay, first point. Remember, experience, that's my X, that's my Y. All right, here we go. Maybe I'll use a light blue. 0, 48, 0, 48, 1, 67, 3, 54, 4, 58, 5, 62, 5, 64, 2 in here, 62, 64, 11, 74, 15, 81, 16, 85, and 23, 92. There's my scatter plot. And again, here's the directions, step-by-step process, how to make a scatter chart. Okay, I'm sure they got some questions for us to answer. Oh, no, they don't. Let's see. Independent variable. Oh, for number 3, now they want us to like sketch a smooth curve through a scatter plot. So in other words, scatter plots hardly are ever a straight line like this, although we can do a line of best fit. Most of them are going to be curved lines. Okay? For instance, mathematicians often look at scatter plots to find the general pattern that data points seem to follow, even if it's not a perfect fit. This process of choosing an appropriate graph shown to represent the trend in the scatter plot is one type of mathematical model. For each of the following scatter plots, sketch a smooth curve through the points to indicate a model you think the data points seem to follow. The line or curve should look like it passes through the center of the cloud of points. It does not necessarily need to go through each or any point in the cloud. looking to make a line graph here. We're doing like, what we want to do is make a line that represents the trend of each of these. Okay. What I like to do is make sure that they're almost like equal distance. So I think it's going to go like this, maybe through there, keep it the same distance. It looks pretty good all the way through, but then we get to here, and that's where we're going to have to curve it. So that looks like the trend for these data points. Curved line, even though it's straight mostly, it's curved. Okay, next one. Selling price versus square footage. Obviously, if you think about this, the larger the square foot, the higher the price of the house. So let's draw a line through this. And again, we don't want to do a line graph. This is not a line graph. We want to do like the average here. And we might have to make a curve. So it goes through there, maybe goes here. Notice that these are kind of like equal distance from the line. Here, so here's my curve. See how these are equal distance from that curve I made. The next one, this looks like it's an upside down parabola. So I'm going to go start from here, and it's going to curve, go through these points like that. Again, not through every point. We want to kind of take through the average of these points. It is also useful to be able to predict the shape of graph from a description of the situation when you do not have any points to plot. To do this, first think about which variable depends on the other. Then consider how it depends on the other variable. Does a variable increase as the other increases, decreases, or does it steadily level off? Number 4.